In our last lesson, we worked on translating between verbal phrases and algebra. Today, we're going to take that one step further and work with translations that relate more to the real world. These types of translations will help us build a bridge between the real world and the mathematical world, and that'll help us understand how math can be used to solve real-life problems, making it a powerful tool in our everyday lives. Plus, it's a little bit like solving riddles, which personally I find exciting. Let me show you what I mean with two example problems that we'll work through together. Our first example problem says that Jake plants a new tree that is 1 foot tall. That tree is expected to grow 2 feet per year. Write an expression for the height of the tree after y years. Since we're writing an algebraic expression, we know that we'll be working with variables, coefficients, constants, and operations. Our goal, again, is to identify key words that will help us recognize these parts of the expression. As we saw in our last lesson, there are many different strategies for tackling this type of translation problem. One approach could be to circle all the key parts of the expression. So let's see. Jake plants a new tree that is 1 foot tall. That tree is expected to grow 2 feet per year. Write an expression for the height of the tree after y years. Now let's attempt to translate and organize these parts into an algebraic expression that accurately describes this real-world situation. The tree's initial height is 1 foot tall. This is a constant because it just is 1 foot. There's no variable with it and there's no number multiplying it. We could represent this as 1 in our expression. The tree is expected to grow 2 feet every year. Grow is a keyword for addition because height is being added to the tree. Other keywords for addition in problems with real-life applications could be speeding up, getting heavier, filling up, getting hotter. These are all relating to the operation of addition. So, Jake's tree is expected to grow 2 feet per year. So, I know I'm going to have a 2 somewhere in my expression. Now let's see. It grows 2 feet per year for y years. Well, per here means that it is going to grow 2 feet every single year. It'll happen over and over and over again. So this repeated process means that per is representing multiplication. In this case, it's happening y number of times. So we can write this as 2y. 2 feet times some y number of years. Putting it all together, our algebraic expression is 1 plus 2y, which represents the height of the tree after y years. It starts off as 1 foot and then grows 2 feet every year for some unknown y number of years. Great work! Let's try another one. Our second example problem says that Grandma Remy baked 60 cookies and wants to make sure that there are an equal number of cookies per grandchild. Write an expression that represents how many cookies Grandma Remy's ex-grandchildren get. I'm going to go ahead and circle all the important information first. Grandma Remy baked 60 cookies and wants to make sure that there are an equal number of cookies per grandchild. Write an expression that represents how many cookies Grandma Remy's ex-grandchildren get. All right, so I know that my algebraic expression is going to have the constant 60 somewhere in it. But what else? Well, let's think about this situation in real life. If you baked cookies and you want to share them equally with people, how would you figure out how many each person gets? Well, you would divide the number of cookies by the number of people. So Grandma Remy will want to do the same thing here too. Dividing the number of cookies which is 60, by the number of grandchildren, which is how many? X. Exactly. That will tell us how many cookies each grandchild gets. Let's look at how the keywords fit this scenario. Grandma Remy has 60 cookies per grandchild. So the word per here is a keyword for division. But wait, per in that last example was a keyword for multiplication. And this is because the keywords per and similarly every can be used to represent both multiplication and division, depending on the context of the situation, of course. Usually, if the keyword describes a constant rate or a repeated process, like a tree growing 2 feet every single year, then it means multiplication. But if the keyword is used to find equal shares, like cookies per grandchild, or a ratio between two quantities, like how many miles per gallon someone drove, then that's division. With more practice, you'll be better able to spot the difference. Now, you might be wondering, how are these expressions actually useful? Well, when translating verbal information, we can represent real-world situations using math. And this allows us to answer questions and solve problems related to a scenario, like figuring out how tall Jake's tree actually is after, let's say, 5 years, or figuring out how many cookies each of Grandma Remy's grandchildren actually get if there are, for instance, 4 of them. We'll need to learn how to substitute and evaluate algebraic expressions in order to be able to answer those types of questions. And that is exactly what we're going to do in our next lesson. But before we move on, I want you to practice translating more verbal phrases to algebraic expressions using the additional practice found in your PDF. Once you feel confident, go ahead and complete the practice game. Then you'll be ready to dive into substituting and evaluating algebraic expressions. See you next time!